Hello and welcome to this physics video, AC circuits and transformers, U12.ACT2. And what we will be doing is applying the transformer equation to solve problems involving step-up and step-down transformers. So the equation is right here, the transformer equation. And it says, what it says is the induced EMF in the secondary equals the number of turns in the secondary divided by the number of turns in the primary multiplied by the induced EMF in the primary. And there are two types of transformers. We have step up and step down. Step up is when the number of turns in the secondary is greater than the number of turns in the primary, and the induced EMF in the secondary is greater than the EMF in the primary. And the step-down transformer is just the opposite of that. When the number of turns in the secondary is less than the number of turns in the primary, the induced EMF in the secondary is less than the EMF in the primary. So now that we know that, let's try some problems out. And what we have here is a step-down transformer is used to provide power for an office building. The transformer has 2,500 turns in its primary, a potential difference of 5,700 voltage in its primary, and a potential difference of 140 volts in its secondary. How many turns are in the secondary? So to start this out, we're just going to bring down our equation. And let's plug in what given values that we have. So we have the transformer has 2,500 turns in its primary, and in its and what we're trying to solve for here is the number of turns in its secondary. So we're going to put an X here. The potential difference in its primary is going to be 5,700, and that is all going to equal 140. And as you can see, this is a step-down transformer because it applies this rule right here for a step-down transformer. So I'm going to need to get out my calculator, and we need to do some math. So what we get here, just to make it look a little better, is 140 equals 5,700 X over 2,500. So what we're going to do here is multiply 2,500 times 140, and we get 350,000. Okay, let me do this to make some room. Didn't really make good use of my room here. We get 350,000 equals 5,700 X. Now we just need to divide 350,000 by 5,700. And our answer for the number of turns in the secondary is 61, and we're going to round to the whole number here for turns. We get 61.4, and so we're just going to round that down to 61. So we get 61 turns. And that is the answer for that question. Let's do another one, an example of a step-up transformer. A step-up transformer has a potential difference of 14 voltage in its primary and a potential difference of 3,000 volts in its secondary. If the number of turns in its primary is 20, then how many turns in the secondary are there? So again, we're going to bring down our equation. One second. Okay. Okay. So let's plug in our given values. We have a potential difference of 14 volts in the primary, a potential difference of 3,000 in the secondary, and the number of turns in the primary is 20. And then we're just trying to solve for the secondary turns here. So what all we need to do first is multiply 20 times 14. And we get 280. So it is 3,000, and also we multiply 3,000 in x. So we get 3,000x equals 280. And we're going to need to divide 280 by 3,000. Or yeah, 3,000. And we get a pretty ugly number here. 0.09 and then 333 repeating. So we're just going to call that 0.93. And that is the amount of turns in the secondary. So thank you for watching, and have a good day. I hope you enjoyed the video.